music practice at this time. It's about aerodynamics, flight theory. That's what we're going to do. And we're going to talk about two important things in aerodynamics: work and energy. Work is not your it's not the work that you normally think about, like going to work, uh, stuff like that. It's not the type of work I'm talking about when it comes to aerodynamics. Work in aerodynamics is done when when a force moves something, you know, in the direction of the force. Okay. To There's no work without movement. For work to be done, something has to be moved. Okay, a force has to move something within some distance. Force distance. An example, let's say you have a big table, a heavy table in your living room, and you want to push it. Okay, you want to push it, and then to do so, you it would take like 3 or 4 people to do so, but you want to do it by yourself, so you try to push the table. But no matter how much energy you spend to push the table, if it doesn't move, you have done no work. So you try to push the table, it's not moving. No matter how much force you apply to it, if it's not moving, you have not done work in aerodynamics. Okay, so that's a big difference between your regular definition of work. Okay, that's one thing. The other thing I want to talk about is energy. By the way, work. The formula for work is force F times distance, and the answer is in foot-pound, because you have force and distance. So work equal force F, force times distance. Okay, so now let's move to energy. What is energy in aerodynamics? Okay, we just talked about work. So energy is the ability to do work, the ability to move something something to a distance. Okay, so we know that energy can be in many forms. Got heat energy, heat energy, chemical energy. So there are different types of energy, but the type of energy that we deal with in aerodynamics is the mechanical energy. In aerodynamics, in aviation, we deal with mostly mechanical energy, and there are two types of mechanical energy: potential energy, PE, and kinetic energy. Two types of energy. Then if you add those two, if you add them together, potential energy PE plus kinetic energy KE, and you get TE, which is total energy. Total energy equal potential energy plus kinetic energy KE. Okay, so there's potential energy. In potential energy, there's no activity, there's no movement. It is just a matter of just waiting to act. Okay, that's potential energy. An example of potential energy, let's say you have a in your car you have a full tank of gas in your car. It's there, but your car is parked. Your car has been parked for a week. So the gas in your tank is not doing anything. It has energy, but since it's not doing anything, you're not driving the car, it's not in use driving your car, that energy is potential energy. Okay, now that's PE. Okay, now once you get into your car, you start your engine, your motor, then you start driving. The gas in your tank, has been converted. The potential energy of the gas in your tank has been converted into kinetic energy, because with kinetic energy there's movement, there is activity. Okay, so now one thing that is very important to know, that according to the law of conservation of energy, total energy must remain constant. The total energy TE does not change. That remains constant. but potential energy, PE, and kinetic energy, KE, can change. So one type of energy can be transferred to another type of energy. You can convert potential energy into kinetic energy, but the total energy, which is PE, potential energy, plus kinetic energy, that that uh, that doesn't change. So the formula to calculate potential energy is PE equal let's see, weight of the weight times height. So it's going to be PE equal W, weight, times H, which is height. Okay, let's say if you have water in a barrel, okay, and then the water in the barrel has been sitting in your backyard doing nothing, and then that's potential energy until you use it, maybe to run a generator, for example. Okay, so that's potential energy. So to calculate that potential energy, you just take the weight of the barrel of the water in the barrel, and you multiply it by the height of the barrel, and then you get your potential energy. Now, kinetic energy is a function of the mass. Okay, let's take the water in a barrel. For example, the kinetic energy is a function of the mass, okay, and the velocity. A function of mass and velocity. So the formula to calculate potential energy is 1/2 times mass times velocity square. So let me repeat that. No. I think I said the potential energy. What I meant is kinetic energy. Kinetic energy is a function of the mass of the water in the barrel and its velocity square. So the formula for kinetic energy is KE is 1/2 times mass m times velocity square. Okay, so 1/2 m velocity square. So that's work, potential energy, and kinetic energy.